welcome back. And this week we're going to be looking at our grade 3 coding curriculum expectations found within the new Ontario math curriculum. And in this particular one, we're building off of our grade 1 expectation of sequential coding, our grade 2 expectation of concurrent coding, and now we're going to get into our repeating events for our grade 3. You'll notice though, again, we don't want to just do repeating events, but we actually want to build all 3 of them into it. So we want to come up with coding that's going to include the sequential and the concurrent as well as the repeating. And so when we think about this, this actually lends us again more to our number lines that we've been working with in Math Up. And the reason I say that is in our number lines, traditionally we would see something like this, where we're going to have a point at the beginning, and we're going to have a point at the end. And so what we've created here is really a line segment. But a repeating event, especially in coding, is going to have a start point, but it's most of the time going to just repeat forever. And so if we think in terms of more of array, that's really what we tend to see more in terms of those repeated events, where you have that start point, but then it just kind of goes on forever. You certainly have the choice of doing either way, though, within our coding. And so, again, you could simply do your skip counting and have a start and end point, or you simply have a start point. Another way of thinking about it, though, is from our circle standpoint, where we know that if we break it into our 4 quadrants here, we have our 0, 90, 180, 270, and then we have an option of how we want to describe this. This could be 360. It could also, however, simply be 0 again. And so it could be repeating in that aspect, but if we were to call it 360, we would then have this one be the 450, this one would be the 540, and so on, and that's still a repeating event. And finally, if we think in terms of even an octagon, we understand an octagon to represent the same type of idea, where if we take our line and we go to our center point, I'm a little bit off here. I am actually even creating a repeating event here, but it's more than that. I actually have concurrent events going on, and that I can think of it in terms of rotating in this fashion. I can be rotating in the opposite fashion. I'm also sequential in terms of the degrees that I have going through here, where I'm simply counting up. And then the repeating aspect would be to simply repeat over and over and over. And so that's, once again, a physical representation of all 3 events taking place within coding, lending itself to a geometrical standpoint. Once again, we're going to hear from our student ambassadors, and they're going to show you their ideas as to what you can do both in Scratch and Lynx Coding with all 3 of these aspects involving, again, the sequential, the concurrent, and repeating events. So thank you for listening, and we're going to turn it over to our ambassadors at this point.
Okay, so I have my repeat star. And how I did it was in events. I got the if I clicked like every other thing. Down here I downloaded pen. I did erase all, then pen down, down there. Then I went up to motion and just put a series of point interaction, move this, and this is what I got. Hi everyone, this is my third Scratch project I'm doing as by Mr. Moore, and it's called Unknown on Scratch because I didn't know what to name it. Anyways, here's how it works. And the arrow goes here and will constantly keep going in a circle forever. Alright, here's how I did it. So, I don't know if you noticed, but I made 4 super tiny balls at the corner, and then I did this code. Glide 1 second to just ball 1, which is, I think, right here, and then point in direction minus 90 degrees, which is pointing towards ball 2, then glide to ball 2, so on and so forth. And I put all that code in a forever loop, as you can see right here. Bye everyone. Thank you for listening, and bye.
Okay, so today we are going to be learning about repeating events and using Lynx coding to do so. So what I have here, it's pretty cool. You can do a lot of things with it. So basically, I'm going to click on this turtle, and I'm going to click on the rest of the turtles, and they're all going to make a different pattern. So you can see how they're working. I'm going to let it run for a little bit. This should be good. And now I'm going to show you how it works. So you can alter a lot of things with this to make it your own, but I'm just going to show you the concept. So basically, to make it create a line, you're going to use the pen down command or PD. Then we're going to use the set color command so we can change the color. Now it should be in like quotations, so green, blue, red, pink, orange, whatever you want. Then we're going to use the forever command. So when you use the forever command, make sure to put a space, then a bracket, then what you want the turtle to do. So this will make it go on, well, forever. And then it's basically just a matter of using the right and left commands to make it turn, and the forward command to make it move, and if you want, the wait command to create cool patterns. And then you can alter that. Like here I did right 105, forward 90, and wait 2. But here I did left 70, forward 60, and wait 1. And that's all you really need to know.
So as you can see, this is my project. And as you can see, all my turtles are moving in 4 directions. And the only way I can stop it is with this button that I created that says stop. So the way I made all my turtles move in different directions is with the procedure that I named one go, which made my turtles glide 104 forever. So that means they can't stop until I make a procedure, which was a stop all procedure that would make all my turtles stop.
So finally, as you can see from our student ambassador examples, when we go back to the key concepts within the Ontario curriculum expectations, you'll notice that it also says that code can be altered to develop students' understanding of mathematical concepts and to ensure that the code is generating the expected outcome. Altering code to use loops can simplify instructions while generating the same outcome, and the placement of a loop in a code can affect the outcome. Finally, changing the sequence of instruction in code can sometimes produce the same outcome and can sometimes produce a different outcome. And so you will notice that as we continue to move through these instructional videos, our coding is actually becoming more simplified and it's becoming more succinct. And that's always the goal and the objective that our ambassadors are trying to work toward. And you may notice in the very last one from our fourth ambassador, it was an extremely simple code, but achieved really the same type of effect as some of the earlier videos. And so I would encourage you to copy the code if you can and play with it and see if you change a particular line, what effect does that have? If you're working in Scratch, move the blocks around, see what difference that would make, see if you can replicate what our ambassadors have done as well. And that will give you a greater sense of understanding as to how these things can be changed. Thank you very much. We'll see you in the next video.